Okay, cool. So yeah, a really, really warm welcome to everyone who's joined. It's really, really great to see so many people from so many parts of the world. And yeah, it's, you know, been a challenging time for a lot of people over the last few weeks. But yeah, this is, I think, a fantastic opportunity to, you know, make the most of it, the kind of increased focus on virtual events, and to have a fully worldwide Kotlin event, which is really awesome. So yeah, this is a first virtual event and our first joint event with the Athens Kotlin User Group. So yeah, big thank you to Antonis and Telgis for co-organizing this. And yeah, shout out to also all the other countries, so people in Dublin, people from Northern Ireland. I know we have some people from Belfast joining, some people from Scotland, some people from Toast in the US. So yeah, you're all very, very welcome. And if there's anyone who's joined from any other country, please do post in the Zoom chat. Let us know. It'd be really cool to see all the countries that are dialed in. So yeah. Big thank you to our speakers also, Georgios and John. So really looking forward to these two talks. I think it's really, really great for a lot of reasons, but I think one of the big ones with these two topics are, you know, people often say that Kotlin events and conferences are too Android focused, but yeah, it's great to see all the different platforms that Kotlin can be used on. So yeah, Georgios with a backend framework for Kotlin, being used with Kotlin. Really awesome to see more adoption on the backend. I know in Toast, it's our backend adoption has really taken off. Our Android adoption has been pretty complete for a while, but it's great to see. Makes me very happy to see more adoption on the backend. So looking forward to that talk, Georgios, learning about Quarkus, and then John O'Reilly will be talking to us about Declarative UI and Kotlin Multiplatform. So two really interesting topics, and again shows the real power of Kotlin and how it can be used everywhere. And yeah, John's going to be live coding an example for us, so really looking forward to that. So yeah, I'm just going to hand over to Athens now. If Antonis and Telgis, you want to say a quick hello before Georgios gets started?
Yeah, well, hello everyone. Welcome from Greece. Hope you are all doing well. We're excited about this cooperation of our user groups, and we are really looking forward to the presentations. So I don't know if you don't want to add something, we can continue with George or.
Cool. I'll stop sharing. Yeah, whenever you want to get started, Georgios.
So, can you see my screen?
Yeah.
Yes.
Excellent. So, first of all, thank you very much for having me here, folks. It's a great honor to be able to talk about Quarkus in this Kotlin event. I haven't been using too much Kotlin lately, but in my previous job, I sure used it a lot, and I really enjoyed it. So I'm excited to be able to talk about Quarkus here in the context of Kotlin. So let's get started real quick. Let's see. Okay. A little really quick about me. So I'm a software engineer at RedHat. I've been with RedHat for the last 2.5 years now. I work on the Spring team at RedHat, but these days I've been working full-time on all things Quarkus. Other things I've been talking the last year and a half at various conferences. This photo here is from DevOps Belgium, and I also am a co-organizer of the Athens Kubernetes Meetup. So when being at RedHat has really given me a great opportunity to interact with all you great communities out there, and it's really been exciting. And you can find me on Twitter at geoand86 later on if you have any questions or anything. I'll be happy to answer. So let's get started to what is Quarkus. So what we see Quarkus is like an open source stack for you to be able to write, I would say Java apps here, but I should probably be saying JVM apps. So basically, you could see it as like a framework, like analogous to what you would do with Spring Boot or Wildfly Swarm, which was renamed to Thorntail or Micronaut, things like that. Those are the frameworks that are most comparable for folks that don't have like a too heavy backend background. They should, I'm sure like everybody's aware of Spring Boot. And the architectures we see Quarkus targeting are basically applications that run on the cloud, like they're cloud native applications or microservice applications or even serverless applications. That's not to say that you can't write like a big monolith in Quarkus, and you can, and you'll see a lot of benefits doing so versus like choosing something else. But the main focus and like the problems that we try to address as a priority are the problems that we your application can't just collapse on the first like network failure, so you'll need fault tolerance, you need to have metrics, health, stuff like that. So that's I'm trying to give you a sense of the types of problems we're trying to solve. And since it's hard to describe Quarkus without you actually seeing it, I'm gonna attempt to do a real quick demo so you can get a feeling of like what Quarkus really is before I talk about more details. So what I have here is I have a project, Quarkus Kotlin project that I've created. We have command line tooling and a website that allows you to create this. I already have it created here, like just to save time, a few seconds for time's sake. But what you'll see here is that it's basically a Maven project. It could be Gradle. I chose Maven because I'm more familiar with Maven. And it has the Quarkus dependencies, and it also has some Kotlin stuff in here. So what I'm going to do now is I'm going to start the application. Because I selected the application to be in Kotlin, to use Kotlin, it generates like some scaffolding in Kotlin. So here you see an endpoint, a REST endpoint that will just return hello. And let's get started and see what that actually does. So what I'm doing here is I'm doing mvn Quarkus dev. Oops. Yeah. Sorry, I need to do a clean before because I cleaned up I deleted I was doing the demo earlier, the practice, and I didn't clean up stuff. So what we're doing is we're starting Quarkus in dev mode. And what dev mode is we see it as like you start your Java application and then you don't have to restart it at all. You just write code and stuff automatically happens. And that's what I'm going to show you here. So here, let's say the endpoint I created was the hello endpoint. This you can't really see it. You should be able to see it now. So this was a JAX-RS endpoint. Hopefully some folks are familiar with JAX-RS. If you're not and you're more familiar with Spring MVC, you can see it as like it's pretty much the same thing, just like different annotations. And we do support Spring MVC too, but I don't have enough time to like demo all that stuff. So what I did here is I just made it when you hit hello, it returns hello. But now I'm going to change the code. I'm not going to restart anything, and I'm just going to refresh the browser, and I'm going to get hello with 3 exclamation points. I'm going to change it again, and hello. So that's the power of this Quarkus dev mode that we have. Like you just hit Quarkus dev either from Maven or Gradle, and it automatically enters like an interactive state. So obviously I'm going to want to do a lot more stuff here than simply create a endpoint that returns the same thing. So I'm going to say I want to try to get a query param here going and see if I can get it right. Let's see. This is name. And I'm also going to give it a default value of the world. So hello and yes, name. So I'll just restart here. I'll get hello world. That's excellent. If I give it the query parameter expects, I get hello George. So that's cool, but it's like really simple, right? So now I want to return some JSON. I want to actually do some actual Kotlin. So I'm going to return a JSON object. I want to say greeting. I want to make this a, oops, I clicked there, something there. So I'm going to make it a data class, and I'm going to give it a val message property, message string. And now I'm going to make this thing here return a greeting instead of the string. And I'm going to go application JSON. So, and I'll restart, and that you just see it automatically works, right? I don't have to do anything. It's like what people like in Node.js are familiar with. You just code and refresh the browser, and they automatically see changes. That's the experience we're trying to bring here. So that's all nice. But let's say we want to like move. Let's say this was the business logic here. We want to move it out. What would we do? If you're familiar with dependency injection frameworks on the back end, like CDI or Spring, we support both of those styles. I'm going to show CDI here. So I'm going to say, I want to call this like a greeting service. Greeting service. And I want to make it a singleton. And I want to say function greet. It's going to take a name. Oops, sorry, that's Java. That's Java for me. Name, and it will return a greeting, but I'm missing something here. So what I want to do is I want to make the prefix configurable as well, right? And I don't want to have it hard-coded in code, so I want to make it a property. So I'll go here. I'll go to application property. So most of you, anyone who's familiar with like Spring Boot or something, knows the application property is where you configure stuff. Same thing with Quarkus. So I'll go greeting prefix hey. I'll go to the greeting service, and I'll inject that property as a constructor. Constructor property. Now let's say prefix string. So we're going to need one annotation here, and this is from this is the micro profile. Micro profile, for those who don't know, is a set of specifications and libraries that are meant to address like a lot of cloud native concerns for Java. So Quarkus implements or reuses a lot of these libraries to provide some of the functionality, and one of the functionalities is centralized configuration. So what I'm going to do here is I'm going to inject the greeting prefix property. That's what I call it, right? Yeah, greeting prefix. And here it's name. So I have to give it a name, and I'm going to say here, I'm going to say it's going to be prefix and name. And now I'm going to take this, the greeting service, which is, let's say, the business logic, and I'm going to inject it inside the class that actually returns the response. So I'm going to say private val greeting service, and that's all that I need to do, because this is a bean here, CDI bean. It could be a Spring bean, but it's the same thing. And I'm injecting it in here. So then I can use it inside each of the methods. So I'll go greet name. And now, hopefully, if I haven't made any mistakes, I see hey George, because hey is what I got from here. I can change it to say hola Spanish, and it just works. So what I want to show here is that you can add classes, you can add code, you can change configuration, and things just magically work. So now let's take it to another level and try to add some database. A simple, very simple interaction with the database. So what I'm going to do is I'm going to configure. I have a PostgreSQL database running as a Docker container in the background. So I'm going to copy and paste the configuration that I need because there's no way I can get this right from the first time. So all I'm doing is I'm configuring where the URL, what Postgres I'm using, username, password, and I'm also configuring. I'm going to use Hibernate. And so I'm telling Hibernate to drop and create the database every time. And I'm going to seed the database with some data. And what Quarkus has for that to make that super easy is that it has this notion of the import SQL file. So you just create the import SQL, you write your SQL statements, and those will get executed once the application starts. So I have that in place, but what I I forgot to do is add the actual dependencies. So there's Hibernate, ORM, Panache. I'll tell you what Panache is in a second. And now I'm going to use the Kotlin specific module to make it, which we use to make it easier for more Kotlin friendly, more make the API more Kotlin friendly. GDBC, PostgreSQL. Oh, something happened here. Yeah, I'll have to restart the Quarkus dev because I did something and killed it. Oh, yeah, it was couldn't find it properly. Anyway, so I'm going to configure SQL, PostgreSQL. I got that. Have the Kotlin stuff. So now I'm I'm going to write a simple entity, Hibernate entity, or JPA if you prefer. Sure, most of you have done backend work. I know what this is. This is just a Java representation of a table, which the table in this case is known fruit. I'm creating a fruit to represent these fruits that I installed here. So we have, yeah, this one I need to say name. And I'm going to make this extend Panache entity. So what this is doing here, actually, I want to create a active record style pattern. Now, the active record style pattern, as you may know from, let's say, like Ruby on Rails or something, you don't need an extra class to access the database. What you're doing is you're using the class that represents the data to be able to interact with the database itself. This isn't the only way that you can do it in Quarkus. You can obviously use the repository pattern, or DAO pattern, as some people like to call it. But I wanted to show you this since it's a lot faster to do. I'm going to have a companion object, which is the Panache companion. And this is the object that's going to give me all the cool methods that I'm going to need, that I'm going to use to interact with the database. And I'm going to add the field, string. So there's the field here, the name field, and now I want to have an endpoint to, let's say, expose all the fruits. So I'll go fruit resource and path. So path fruit, and let's say I want to return all fruits. So I'm going to go list all and fruit list all. And I'm going to do get, and I'm going to do produces. It's going to be an application JSON, media type application JSON. Okay, so let me restart dev mode again. I made a mistake earlier, and that's why it cut off when I was adding the dependencies. Normally, it wouldn't have to do that at all, but in this case, I made a mistake. Anyway, you see that the SQL statements that Hibernate generated to insert the data based on what I added here. So everything's ready to go. Obviously, this will continue working, but the cool thing is that I do fruits. Oh, it's fruit. I mean, so this is the other thing. Quarkus gave me this awesome error page. I made a mistake in the endpoint, and Quarkus tells me automatically, you know what? That's not right. You've got to use fruit. So I hit fruits, and automatically there. And you see how easy it was, right? This is like an experience that's not that most Java developers, backend developers aren't used to. Like, you write so little code, and like so much stuff just happens out of the box. The other cool thing that I'm gonna show you, but I'm not gonna compile it. So we have awesome integration with GraalVM native image, which I'm gonna talk about real soon. But you can think of it, GraalVM is like what Kotlin native is, where you can take a Java application and compile it down to native form on the platform you're targeting. So that's what GraalVM is, but it's targeted for Java, and it's for like a larger set of applications. And we can use that out of the box, and you can build a native application, a Linux binary, and that would take like a minute or so. So I'm not going to do it. I'm just going to run it. So here's the application I've run I've built before. I'm going to run it now. And you can see that it started in 0.034 seconds. And that includes the database, the going to the database and inserting and come back. So this is huge when it comes to be able to write Java applications that start this fast is huge for both microservices, and it's a prerequisite for if you're going to do serverless at all. So we're just going to make sure that this works. And yeah, it was fruit. So when I built it previously, it was fruits. So I hope that this was like a really quick overview of what the code actually looks like and what you can achieve And now I'm going to go back to the slides and talk a little about what Quarkus is and what are some of the other features it has and why we did Quarkus. So why Quarkus? The Quarkus is very much a product of its time, right? So so many teams are moving from very large monolithic applications that are deployed, let's say, like very infrequently, to they're breaking up these monolithic applications or starting new applications using microservices or even serverless, where you have these smaller pieces that are updated a lot more often. And because they're deployed automatically, in a lot of cases by using a platform that scales based on load, these things need to start really fast. And because the way we scale applications now isn't like we buy a bigger machine to run our application, what we usually do is that we run more copies of our application. And because we're doing that, we need to consume a lot less memory. That's why up until now, Java hasn't like enjoyed too much spotlight in, let's say, like serverless space, or even in the microservices space. You see a lot of people like they say we start with like something like, let's say, Spring Boot, for example, but then they see like, oh man, every instance of my microservice consumes like 512 megabyte or a gigabyte of RAM, and I need to run like 10 or 15 or 20 of these, and that cost, the memory cost, really goes up from your cloud provider, and you obviously don't want to be paying more. So you want to use microservices to leverage the advantages they give you, but you don't want to have to pay through the teeth to do that. So why do you go through the pain of going to microservices, right? So there's a lot of pros and cons, but the way we usually see it is like the ultimate goal for us as, let's say, business people that have actual business applications is that we want to improve our agility, right? We want to be able to produce more value to our customers more quickly. And we want to be able to continue to provide that in spite of whatever failures or problems we might have with our infrastructure. So what we do is we break up our big application into smaller parts, and we leverage the ability of our cloud provider or our container platform like Kubernetes to deploy as many instances or in different parts of our application as we want. So it's as hard or as easy to deploy like one microservice or 10 microservices. There's no difference. Whereas in the old days when we had application servers, we didn't have this flexibility, so we were pretty much limited whether we wanted to or not to like these very big monolithic applications that ran in these gigantic application servers. So, but remember that we went to these microservice architecture. So that means that we have a lot of small applications running a lot. But for anyone that knows like even the basics of the internals of the JVM, that comes at a cost. And that comes at a cost because when we like intuitively think that, oh yeah, I'll just start Java minus jar with XMX like 128 megabyte or whatever, there's a lot more RAM that's consumed by the JVM than that 128 megabyte, which is the heap size, which is what you see here on the right. So the JVM itself allocates a lot more memory for various functions like just-in-time compilation, garbage collection, code caches. All that stuff takes up memory. So when you start with XMX 128, that's just a heap. You could end up with like having more than 200 megabyte easy of actual consumed memory. So when you're scaling your application to tens or maybe hundreds of instances, then you're paying this cost. Your application, the data of your application is this on the right, but the fixed cost you're paying is all this here. And you want to reduce that as much as possible. So that's where one of the main focuses of Quarkus. It tries to reduce this fixed cost as much as possible. And how does it do that? It does that by reducing the metaspace. The metaspace is the amount of RAM, the space of RAM that's taken up by the JVM in order to have metadata for each class. So each class ends up in the metaspace. So if you have like tens of thousands of classes, your metaspace is really large. And with Quarkus, you have a lot fewer classes, and I'll explain why later on. So your metaspace, the fixed cost you have for the memory consumption is a lot lower. And we'll see graphs of what that means in practice. So like I said earlier, a lot of teams that wanted to adopt microservices didn't necessarily love the JVM for that because of the high memory requirements. Because you got to remember that Java became popular and was optimized for late 90s, early 2000s model, where we were trying to get as much throughput as possible from a single process, and that was the expense was that we took up more memory in order to gain more throughput. But for the microservices, that isn't exactly the scaling model we have. So a lot of teams are going to like Node.js or even Go because these runtimes had better memory performance and obviously faster startup time. But we'll see that with Quarkus, that's not exactly that let's say dynamic has changed, and the JVM is a lot more competitive now. So what is Quarkus? What we see Quarkus as being like 4 things. Well, here I said we break it down like where does the name come from? It comes from like quark, which is the elementary particle, and us, like us, hardest thing in computer science. But let's get back to the real stuff. So what is Quarkus? We see Quarkus as 4 things. First thing is developer joy. So as you saw earlier when I was coding, I did like very little configuration in a single file. There's one file that I had to specify just a few properties for Hibernate. To run the dev mode, I just ran one command. I didn't have to do anything else. So what we really mean here is that we as a framework, we have focused we're focused a lot on making you as productive as possible. We want you to be able to code your business requirements as fast as possible and have fun doing it while exploring all the features Quarkus has. So Quarkus has a ton of features, but as users, you might not have to interact with all of them. And the common cases are made very, very easy. Another part of that is that the GraalVM native image compilation that I mentioned earlier, if anyone has tried it outside of Quarkus, like bare bones native compilation, it's super hard to get right. There's too many options, too many flags, too much monkey patching you have to do to libraries. Quarkus makes that all disappear. So just with like one command, Maven or Gradle command, you just build your native image, no hassle at all. Second benefit is what we call a supersonic subatomic Java. So you've probably seen that as like a subtitle to what Quarkus is. And what we really mean is supersonic means that it starts really fast. Subatomic means that it consumes very low memory. So in this graph here, for a simple REST application, which is like the initial version of what I showed you, a competing framework, like which is in the right, I can't really say what it is, but you can probably guess anyway. A competing framework for just like a hello world application would take like 136 megabyte of RAM just to start the application with the hello world. In Quarkus, we see that if you profile your application, the same application in Quarkus, you'll see that it takes about half that, which is 73 megabytes. If you then want to go to GraalVM native image, to go the extra step, then you could drop that to 19 megabytes. So this would be a native executable that will only take 19 megabytes for just when you're starting a whole world application. If we get to something like more real, which is like something like the second thing I showed you, the second part I showed you where I added some database access, the traditional Java framework would take like around like 10 or 10 megabyte. Quarkus in JVM mode would take only like 145, so it's like maybe 60%. And if you want to take that even further to native image, you want to go GraalVM native image, then that drops to 35. And that's huge. I mean, you saw how fast it started when I started. So it was like 14 milliseconds or 30, whatever it was. And it consumed a lot less memory. And here's the supersonic part. So it's pretty much what I said earlier. A traditional Java stack, and this here, I've got to say that we're counting time to first response. So what this means is the real time that it takes for the framework to respond to the first request we give it. So it's not, a lot of frameworks like do this lazy loading stuff, so they don't load stuff until you actually need it. But that doesn't really help you when you're a developer, you're hitting your browser and you want to see stuff happening. What you care about is how long it takes to actually get the response to your first request. So that's what we're measuring here. Competing framework can take like 4 seconds, maybe less now with newer versions. Maybe it's down to, I don't know, like 3 or something like that. But still, Quarkus, like in almost in all cases, in any modern machine, will start in under a second for sure. And if you go GraalVM native image, the numbers are like a joke. It could be 10 or 20 or 30 milliseconds. It doesn't really matter. And when you get that low, how long it takes doesn't really matter. When you go to like, you add Hibernate to the mix, so you want to do some database persistence, then the traditional framework would take around 10 seconds, maybe a little less, a couple seconds less. But Quarkus should start in around 2 seconds. In my machine, it starts faster. So it could be, in my machine, I think I've seen it like 1.5, 1.2. So that's with the database. If you go GraalVM native image like we saw earlier, it's like, I saw 30 milliseconds, it says 42 here, but it doesn't make a difference. It's all the same. Third benefit of Quarkus, so that was I was talking about earlier, the second benefit, which is supersonic subatomic. Now, the third benefit is that Quarkus is reactive down to the core. I mean, with all the, nowadays, you all want to create reactive applications in order to be able to scale as much as possible. And Quarkus is reactive down to the core. I mean, it's built on Netty and Vertex, which are reactive frameworks. So all the I/O is reactive I/O. But you, as a developer, don't have to use reactive data types in your applications. Like what you saw me code earlier, and I didn't use anything reactive. It was all blocking stuff. So you, as a developer, have the opportunity to pick and choose if you want to use reactive or not. And you can mix the two styles in the same application. And here, the stuff I'm showing here is like how you could use RxJava or Project Reactor or stuff like that, or this new library we have, which is called Mutiny, which is an evolution of RxJava, making it with more types and easier to use. But what you have to take away from this part is that Quarkus is reactive down to the core. You can choose to use it or not. And the fourth benefit, and very important, is that you as developers, as backend developers, you probably have used a ton of these libraries and frameworks that I'm showing here, right? And you don't want to waste that. You don't want that knowledge to go to waste. You want to reuse as much stuff as you can. So when I was coding, I reused my JAX-RS knowledge. I reused my Hibernate knowledge. And you want to do that. You don't want, like, at least I don't want, when I'm going into a new framework, I don't want to have to learn everything from scratch. And I don't have to do everything like the super idiomatic way of the framework from day one, because that just raises the complexity for me a lot. So you have all these cool integrations. Of course, there's Kotlin. I have it at the top as a language. So Quarkus is built in Java, but we've made a lot of strides lately to improve the Kotlin support, and that's going to be an ongoing process. We're going to have a lot more support in the future. But what you see here is like you have Spring compatibility, you have Hibernate, you have Apache Camel for integration, you have Netty, of course. You can do a ton of stuff with Kafka, Kubernetes, OpenShift, all this great stuff that you probably already know as a backend developer, so you can get to reuse that knowledge. So you're probably wondering, okay, how did you start that fast? How does it take up so little memory and stuff like that? Well, what's the magic sauce, right? I mean, this all sounds great, but what do you do so differently that allows you to start that fast and consume so little memory? And the magic sauce is that we're doing as much stuff as possible at build time. So when you actually build the jar, or the GraalVM native image, Quarkus is doing a ton of stuff behind the scenes. So it does that at build time, so then it doesn't have to do it at runtime. And that means that when it doesn't have to do it at runtime, first of all, it starts a lot faster, and then second of all, the classes that were used as the framework classes that were used to build all this stuff are not present at runtime. So those classes are all gone, so you can take up a lot less memory. So what does a framework usually have to do at startup time? Well, it has to parse various configuration files. all annotation-based frameworks, like JVM annotation-based frameworks, do class path scanning, and this stuff is slow. Depending on how many jars you have, how many classes you have, class path scanning can definitely be slow. Because you have to search for annotations anywhere in the code, stuff like that. Then the framework has to build various meta models for various libraries or other dependencies it has. It has to build dynamic proxies and stuff like that, perhaps even do class generation, all that neat stuff that super advanced frameworks like Spring or libraries like Hibernate do for you. All that stuff, Quarkus is built to do it at build time. It doesn't do the final thing that it says here because it can't and shouldn't, which is starting an open IO thread. That happens at runtime. But all the previous stuff that is mentioned here, all the, let's say the heavy lifting for preparing your application so you as an application developer can just use these cool annotations and everything works magically. All that stuff is done at build time with Quarkus. And the benefits, as I explained earlier, is that when you move all that stuff to build time, first of all, all these classes that are needed to do all this weird stuff isn't needed at runtime. So my analogy here is like when you think of a Java compiler or Kotlin compiler compiling all that stuff to create the .class files for the JVM, you don't need a compiler at runtime. At runtime, you just need the output of the compiler. So it's the same thing with Quarkus. You don't need all these extra classes that were used to build all this stuff. In build time, you just need the actual outputted stuff at runtime. Another important benefit is that when you do it at build time, then you're only doing it once. So if you're going to create a microservice and scale it to, let's say, like 100 instances, when you're doing all this extra work one time at build time, you're saving a lot of startup time. So, and don't just see it as one time, the one time you start, like go from 4 seconds to 1 second. If you're doing that 100 times, then you have to multiply it by 100. So that's a huge benefit right there. Of course, as you saw in the numbers, there's less time to start and less memory used. And there's little or no reflections or dynamic proxies. You probably don't care about that as a developer that much, that there isn't. But what it actually means is that the less reflection and less dynamic proxies that exist in a framework, backend framework means that the JVM JIT can optimize code a lot better. So you have better throughput and you have less memory consumption. And the other thing is that, before I move here, the other thing is that it makes it a lot easier to build your application on the GraalVM native image, which I'll talk about in a second. So schematically, what does this look like? What is this process of building your jar, your Quarkus jar, or GraalVM native image look like? Basically, the first step is the compilation. So this is what the Kotlin compiler, the Java compiler will create the .class files. Then we have this curation phases. This is where we separate the classes that are needed at runtime versus the classes that are only needed at build time. Then we do a whole lot of stuff in this wiring and assembling phase. So this is where Quarkus magic actually happens. So at build time, we actually generate classes or we transform classes. One example here is that we strip the final modifier from classes in a lot of cases. So as you see with Kotlin, I didn't have to write open anywhere because those are stripped automatically from when Quarkus manipulates the bytecode that the compiler created. So all that stuff gets weaved in together and we create an optimized jar, or if you want to take it to the next step, we feed the optimized jar along with a bunch of configuration we have. We feed it to the GraalVM native image creation process, and then after a couple minutes, you get your native app as a result. So what is this GraalVM native image? You definitely want, if you're doing any sort of back-end work and you're looking at serverless or stuff like that, you definitely need to be looking at GraalVM. And if you do that, you'll appreciate how much Quarkus brings to the table. Because what GraalVM does is it takes your Java application and it creates an assumption that your Java application is what it is at build time and nothing else. So a lot of you probably already do all this cool stuff at runtime, like creating classes or doing this weird reflection stuff, unloading classes, loading classes, changing classes at runtime, GraalVM doesn't allow any of that, which means that libraries that rely on that stuff, which is most of the, let's say, advanced libraries out there, won't work out of the box. So it really thinks that whatever classes you have at build time, those are the classes that you can have at runtime. And it's hard to do reflection, it's hard to do dynamic proxies, all that stuff is hard, but because it assumes a closed world, it can optimize a lot more than a regular just-in-time compiler, a Java just-in-time compiler does, which means that it can throw away so many classes. Like, let's say in the typical example here is that GraalVM, when you're building a native image and you're not using like Swing or any of that UI stuff, it just throws all those classes out. So you get a much smaller native image. So the native image I generated in the demo earlier probably took like, it was only like 40 megabyte or something like that, because there's so much stuff, both from your code and from the libraries you use and from the JDK itself, that GraalVM just throws out. It can optimize out because it knows it's never used, and it knows that stuff's never used because of this closed world assumption. But if you try and use this on your own, like GraalVM on your own, you're going to have a terrible time producing a native executable. And not only you'll have a terrible time the first time, you'll have a terrible time every time you try to like update a library or add some new dependency. You'll probably end up in situations where you can't build your native image again. So that's another thing that Quarkus brings to the table. Quarkus provides a guarantee that all the stuff that's supported in the Quarkus ecosystem also works on GraalVM, also works and is tested on GraalVM. And if something doesn't work, it's considered a bug and it's fixed. So all the libraries, like all the cool stuff for Kotlin or Hibernate and the Spring stuff, all the stuff we support also works on native image. And it's hassle-free to use. You just do an MVN clean package minus D native. So you like add one flag to your regular packaging process, and it just magically works. And that's huge versus spending hours and hours trying to figure out like what the right GraalVM configuration is. Okay, so the benefits that Quarkus brings for GraalVM is like I said, 100% of the ecosystem is compatible and supported. And the other thing, which I also hinted at, is that you don't have to do any of this hard work yourself. Quarkus already has all the knowledge about these libraries and frameworks that in order to make them GraalVM compatible. Plus, because like I said, we know which classes are used at runtime and which are not, we can minimize dependencies, making it even better for GraalVM to actually to help it eliminate even more code. And because we also have this notion of build time properties, so some properties are only configurable build time, we can make it even easier for GraalVM to eliminate more things. Like the typical example here is like, because I supplied the Postgres SQL database for Hibernate, GraalVM will know that like all the Oracle stuff or the MariaDB stuff, all those classes it has in all those classes that Hibernate has for all those other databases, GraalVM knows that they're never going to be used. So I can just throw them out in the final native image, which makes it a lot smaller and makes it consume a lot less memory. So the final slide I have here is like, when would you use the JVM mode versus the GraalVM mode? And what we typically see is that you'll use the JVM mode when you need maximum throughput. So the throughput you get from JVM mode application is higher than you'll get from a native application. But if you also then take into account how much memory the aggregate of the application is, you'll get higher let's say aggregate throughput with the native image than with the number of native image applications you can spin up for the same memory in JVM. But then with native image, you don't have access to all these cool tools in the Java ecosystem, like all the agents and profiling tools and stuff like that. If you need access to all that stuff, you can't use GraalVM native image, or if you need access to all the cool garbage collections that are out there, like new Z garbage collector or Shenandoah or whatever. You have to do the JVM mode. But GraalVM support is improving, so you can expect like some of these limitations to be lifted later on. And that's all I had, I'm pretty sure. And this is where you could, the Quarkus.io is our website, and then there's a chat, Quarkus.io Zulip chat or Twitter. So that's where you'll find a whole bunch of information. Our chat is where all the developers hang out. You can pop on, ask questions. We're typically really reactive, and people usually get their answers really quick. So that's all I had, I think. So I'll stop sharing. Hope I didn't bore you too much with all this stuff.
That was awesome. Thank you. Thank you very much.
Thanks.
Yeah, really great, great live coding, and yeah, very impressive, impressive framework. I guess that's the right word for it. So yeah, question on the chat from Alexandros. Are you planning to support coroutines, for example, using suspend function in a JAX-RS resource to be able to not block the worker thread?
Yeah, so there's so the story here is that GraalVM just came out with proper support, like in GraalVM 21, which was released like yesterday, I think. They released proper support for coroutines. So now Kotlin coroutines do actually work properly and fast on GraalVM. So we're going to start looking into that, and we're also, but the other thing that comes up here is that what we do, we need to figure out a proper way to support it and not block future support for Project Loom, for Java's Project Loom that's coming in maybe a few years, or anyway, sometime down the line where like threads will be super cheap. So we need to figure out a proper model to be able to support all this stuff and not like make hard decisions now that will like kill our Loom support down the line.
Cool. Another question. So, yeah, high praise for the presentation, for brilliant presentation. Thank you. How to create another extension, e.g., Javelin?
Yeah. Okay. So the extension, we have a super big extension authors guide, which will like guide you through all the stuff you need to do. There's so many extensions in Quarkus that there's always code that you can look at to be able to create like whatever you want. So a lot of folks like say people needed to, from the community, to integrate with Gale flogging or something like that. They just wrote an extension and contributed to us. So that's generally not that hard to do, and we're always around to help out. It's just that you need to a mental shift. You need to start thinking like stuff that needs to be done at build time versus what can be done at runtime.
Okay, awesome. So yeah, another good question. So if so much optimization happens at compile time, what is the debugging story like?
Mm-hmm. Okay, so for GraalVM native image, if you go to GraalVM native image, you only get debugger support if you currently, actually that's the current situation, you only have debugger support if you have the enterprise version of GraalVM from Oracle. That's going to change. There is going to be some debugging support, but that's, I think it's like next release or something like that. So for the JVM side of things, the debugging is the same, right? You'll see your typical like large call stack like you would with any other advanced enterprise framework or Spring. You'll see a tall call stack. That call stack might include classes that you didn't write or that you're not going to find in the source code of the framework because they were generated by Quarkus at build time. But it doesn't hinder your debugging experience any more than say when you're using Spring or something like that.
Okay, cool. And yeah, I guess with the mention of Spring, question I had was like the benchmarks, the comparison of the startup times and memory usage were really, really impressive. So are there I guess, public benchmarks that we could, really compare the different frameworks? Are those available, or?
Well, we can't publish stuff that compares, right? We can't publish like us versus whoever else. From what I do know, there are ongoing efforts from like third parties to release these types of benchmarks, and we're also going to make a proper integration with what's that standard benchmark that all the frameworks are on. I can't really remember. Anyway, we can't publish them, but you'll soon be able to find stuff from third parties easily.
Okay, awesome. Yeah, that'll be really good to see. So you're not allowed to publish. I thought companies are allowed to publish comparisons nowadays.
Well,
Yeah.
I guess we can, but we can and we can't. So I don't know. There are legal limitations of what we can and can't do. But we're trying to, as a community, we're trying to stay away of being like too aggressive against our community. Trying to like just show like we're doing cool stuff. Other people are doing cool stuff too. Like you guys and girls get to choose. And another thing we're also saying is that like these standard benchmarks, they're great, but you always need to benchmark for your own use cases, right? Because there are cases where a framework might be poorly optimized for what you're trying to do, and like we might be winning in like 95% of the time, but for like your 5% use case, we might not be good right now. And if that happens, then we also want to know about it, so we can, because optimization is obviously an ongoing effort all the time.
Yeah, cool. And another question I had, so you mentioned that Quarkus is on version 20 something. So I guess when, you might have said this, but when did the project start, or when was 1.0?
So 2020 version was GraalVM, not Quarkus.
Oh, sorry.
That's GraalVM, but they're only using that version because it's like the year 20. So they're using like what IntelliJ does, like 20.1.
Oh, okay.
So Quarkus started, I wasn't part of the team that started it, but from what I know, it started in like, I think it was summer 2018. It was released internally to us at RedHat Christmas 2018. That's when I started working on it. The first public release of Quarkus was like version 0.14 or something like that. I think it was March last year. And now we're at, what are we at now? 1.5. Yeah, I think we're just releasing 1.5.
Okay.
So we're moving like really fast, like one release a month or something like that. That's our target. So we're trying to do time box releases. So far, it's working pretty good.
Awesome. So another question from Alexandros. Which IDE are you using? Looking at the Quarkus support, currently VS Code support seems better than IntelliJ, so we can't use Kotlin there.
Yeah, so I use IntelliJ only, right? That's the only thing I'll ever touch. IntelliJ is coming out with better Kotlin support. They do, better Quarkus support. They do have some stuff, but we've opened issues for them to like make the framework, make the IDE more aware of the framework. They've fixed a lot of stuff. There's more stuff to do. So I just stick with IntelliJ. I mean, it works awesome, and because we're reusing a lot of this standard like Hibernate and JAX-RS, IntelliJ already works with those, so it already understands a lot of the stuff that you're going to do with Quarkus.
Cool. Sounds awesome. Are there any more questions? Okay, cool. Want to say hello to, thanks for posting the countries you're dialed in from. So hello to India, Canada, people from Germany also. So yeah, really awesome to have people from all over the world. Cool. Well, thanks very much, Georgios. Really enjoyed that.
Thank
you.
It
was a great presentation.
Thanks.
Cool. So we can hand over to John. You want to get started, John?
Yeah. Let me just start sharing. Okay. So hopefully you can see my presentation.
Yep.
Yes, excellent. Good start. So I'm going to go through just a couple of slides here, just to give some context, and and then we'll dive into some live coding. So first of all, just to give you some background. So my name is John Riley, as it says there. I work for a company called Neat, and I'm primarily doing Android development. I've been doing that for about 10 years now. But I've been looking into sort of multi-platform capability since about the start of 2019. Sorry, something changed in my video here. Sorry. So the plan for today is to do sort of a somewhat live demonstration where we build out a very basic application. I'm going to sort of overuse the term basic and minimal here probably a bit, but we're going to build out a very basic application that sort of showcases the use of declarative UI frameworks. This is the likes of Jetpack Compose for Android and SwiftUI for iOS. Combined with Kotlin Multiplatform, this is sort of the capability where we can write Kotlin code that's shared and runs on multiple platforms. So I'm not too sure if you are interested in Compose, or people have looked into it a little bit. There's DroidCon online set of talks, and Brian Garner did a very good one about a couple of weeks ago, specifically in Jetpack Compose, and he dives into a little bit more detail in terms of it builds out sort of Gmail. Our examples today would be quite basic, but also the other kind of nice thing from Brian Gardner's talk was he had this very nice metaphor. He described what he was doing as a sort of a cookery show, and he described how it's little bit stuff made fresh and some stuff prepared earlier. So on a similar vein, we're not going to build everything completely from scratch. We're going to start with some basic project templates and sort of build out from there. The project is by definition pretty small anyway, so designed primarily really to sort of demonstrate the key moving parts of a Kotlin multi-platform project, and also Kotlin declarative UIs as well. So what we'll cover, I mentioned, we built out very basic Android, iOS, and macOS app. We're going to use the same shared Kotlin multi-platform non-UI code, emphasis on non-UI code here. The real sort of value add, sort of the value proposition, sorry, to use that term, of Kotlin multi-platform is to targeting shared non-UI code, and that's where its real strength is. Having done that, then you're left, individual iOS or Android developers are left to use their sort of best of breed tools and technologies. So you use, for example, Android will use, in this case, we're using Jetpack Compose, using Kotlin Android architecture components and so forth. If you're doing this today, you're probably using fragments and activities and so forth. iOS is a little bit ahead of the curve in terms of use of declarative UI frameworks. So an iOS developer is more than likely started to use SwiftUI and using Swift and things like Combine, the reactive framework on iOS. So that's the key thing. You target your shared code, and then you focus on from your UI perspective, or it's a sort of broader discussion in terms of how high up the stack your shared code targets, but the flexibility is there, and that's a key part of Kotlin multi-platform. I think that differentiates itself from other approaches, where you have the flexibility to manage, how much you adopt and when you adopt it. And just to mention, there's an ever-growing list of libraries that support Kotlin multi-platform, but these are probably the key ones, the ones we'll use today at least. So Kotlin coroutines, and if you follow these coroutines, you might be aware there's a sort of native multi-threaded version as well, which is sort of separate dependency. I'll talk a little bit more about that later. It should be in the 1.4 release of Kotlin coming out relatively soon. It should be officially in there, I believe. We're going to use Ktor, so the client library part of that. There's also, folks are probably aware, if you work on the back end, there's a server-side component to that as well. Kotlin X serialization, which is a library, serializing, deserializing our JSON. And SQLite, which is a multi-platform library, obviously, for persistence across multiple platforms, which is pretty powerful when you see that. So just, I don't know how much folks here kind of delved into or explored Kotlin multi-platform, but just to sort of, this is a quote from Kevin Galligan in TouchLab. Again, if you follow the world of Kotlin multi-platform, you're probably familiar with Kevin and from TouchLab. They're sort of the pioneers in this space. And this is sort of a lot to unwrap here, but the sort of key point is this optionality, and I kind of touched on it in the earlier slide. That you're free to use as much as little as you want. And the recommendation really is to start off small, take a particular endpoint, take some particular piece of business logic, and adopt that in and sort of build up the infrastructure to support that, and then gradually build out your more and more code that you support or that runs as part of your multi-platform module. And as I said, it's sort of really focused on the non-UI shared logic. And these are the platforms supported, which pretty much most platforms that people would be using today. We're going to talk a little bit, obviously, today about Android, iOS, and macOS. The particular project, the open source project I'm using as a basis for this, this thing called People in Space, which now also has a watchOS. A guy called Neil Sanch contributed a watchOS implementation, and I actually saw a tweet the other day that somebody was going to working on a tvOS implementation as well. And we'll see, you know, the power of sort of Kotlin Multiplatform when it's shared across all these platforms, but almost sort of orthogonal to this to some extent when you start using SwiftUI, for example, and Swift in general. It's almost equally powerful, the fact that you can start using that across all those Apple platforms as well, which is sort of another dimension as well. And obviously we're on the JVM as well. The project, again, that I'm working on today, the sort of the version that's in GitHub also has a very minimal backend implementation that uses JVM. And actually, when you're running your unit tests as well, they're using JVM-based dependencies as well, which is kind of interesting. And Kotlin.js, again, another example in that repo for Kotlin.js, a very minimal one, and then obviously the other platforms as well. Oh yeah, so declarative UI. I was kind of looking for a succinct definition of declarative UI. I don't know, you know, when I sort of started down this path that. Earlier last year, I guess it was, I think a number of us have probably seen the announcement of Jetpack Compose at Google I/O. And maybe like me, it was something out in the future. It wasn't sort of, it didn't really register very much at that point. Then I think literally a few weeks later, I was watching WWDC and they announced SwiftUI. And then I kind of started to kind of go, okay, maybe there's something to this declarative UI approach. And you know, the nice thing about SwiftUI was that it was available in a beta that evening that you could start trying out, and that's where my sort of initial explorations for using it. And when I started using declarative UI combined with multi-platform, it was sort of just seemed very compelling, that combination together. But Jetpack Compose kind of has been catching up a little bit. It's, at least in the last several months, it's now available in Android Studio 4.1 in Canary versions. It's still in a dev release. You know, if you're sort of pulling it in, if you're trying it out, you're probably going to be getting breaking changes at almost every release. SwiftUI is a long way ahead of that. It's sort of available in production versions, or release versions of Xcode, and is, I believe, in some production apps right now. But just to describe declarative UI, I guess the most succinct way of seeing it described is that you, and again, this is where the declarative comes, you declare what your UI should look like in a particular state. And the concept of state is important here, and we'll sort of see that in a little bit. Sort of in contrast to, I guess, what's seen as sort of the imperative, the traditional imperative style, you know, if you're doing Android today, where you're using layouts and you're using fragments. You know, if you're in iOS, you're using storyboards and view controllers and table views and so forth. And you get a combination of things. You know, you have that imperative approach, and you also have this sort of separation of formats, which in theory is supposed to give you a sort of a type of decoupling, a sort of form of, you know, by for example, in Android, having your layout in XML and having your sort of your view logic in a fragment. There's a guy, Leland Richardson, who I definitely recommend following, and he came from sort of the React background himself, and he's sort of the main architect in Google working on this, and he gives a number of very good presentations a number of if you follow Fragmented Podcast, for example, he's talked on that a couple of times, and he sort of dispels that sort of myth a little bit, you know, that separation of concerns. There's a lot of implied coupling that you get in those, you know, that supposed separation, and that, you know, the benefits that you get then from using something like, you know, declarative UI and the approach it espouses, and the fact that you're using a single language to do that is quite powerful. And like I said, it's been popularized by, you know, inspired by the likes of React and Flutter to some extent as well, I believe. This is the repo that we're going to base the talk on. When I started exploring SwiftUI back last year, I have this another app in the open source application for Galway bus timetable, route, bus information, and so forth, and that was my initial sort of vehicle for trying that out. But it's quite an involved one, and it's a lot of legacy to that. So there's a guy called Ken Kusin, who you may follow in terms of in the Java Kotlin world, and he had given this very simple example of Kotlin using people in space, this API to get the list of people currently in space. Not a list that, you know, as you can imagine, changes very often. But it was just sort of piqued my interest, and I thought, okay, this is perfect for what I want here, which is just an optimally minimal project that does the least amount possible to sort of demonstrate the key moving parts of a Kotlin multi-platform project, and in this case using, you know, declarative UI. And that's what we're going to use today. We're going to start with sort of a broken shell of that, I guess, and building that out. And this is the API we're going to use. You know, just simply JSON that returns the list of people in space. And this is pretty much what we're going to be building today. We have in our, you know, below the line here, I don't know how well it shows up actually on the slide, but obviously the bottom section here is our sort of our shared code. You know, our data model, such as it is defined in here in a number of Kotlin data classes. We have a repository representing, you know, sort of standard repository pattern, again, pretty minimal in this case. It has a remote API endpoint which connects to using Ktor to the REST endpoint that gives that information, and uses SQL Delight then, which we'll talk about towards the end of the talk, which persists the data. And then on Android, we're using standard Android architecture components, Android view model, start to use Compose on the Apple products. We're using something similar to the view model. It's not specifically called that, but it fulfills similar purpose, and using the likes of this combined framework that I mentioned, you know, provides functionality very similar. For example, live data, if you use that in your view model in terms of the observability of the information and so forth. And then obviously SwiftUI. And sort of slide aside, at the middle of last year, there's a guy called Jesse Wilson, again, another person very worth following, works at Square, and he wrote a blog article about how in Square they were starting to align their Android and iOS teams. And, you know, there's a number of different dimensions to how you can do that. One approach, you know, if you try to go down, if you can go down the path of something like Flutter, and you try to sort of all in, and you try to develop one code base for both of them, there's other dimensions to that, and he covers, you know, things like having common vocabulary, having, you know, aligned architecture, having iOS developers review Android code and vice versa, and with, you know, with Android primarily using Kotlin now, and with iOS using Swift, those languages are very similar, very easy to read, and particularly, you know, when we talk about the shared code, we're talking about code that is typically not platform specific, so it's even more readable. Okay, so let me let me shift over to this is, sorry, now a second, my thing with my notes is sort of switched off here. Bear with me. Okay, there we go. So we're starting off with this. Hopefully you see Android Studio here. We're starting off with this sort of shell of a project, but obviously, you know, an existing project. And this is actually an interesting point. You know, an important point, I think, is if you haven't looked into Kotlin Multiplatform before, and you're starting afresh, you're just looking to explore, see what it's about, I definitely recommend starting with a pre-existing template. There's a number of good template projects. This particular one is maybe useful just looking at it for the very first time. I mentioned TouchLab. They have this excellent CampKit project, which is, you know, if you want to take a little bit further and you want to sort of build up, you know, see some of the more sophisticated use cases and to sort of see more fully fledged. This kind of skimps on error handling and a few things like that. That project obviously takes a more kind of robust approach to. But a key thing when you're building a multi-platform project, if we just look through some of the modules here, typically, you know, using IntelliJ or using Android Studio, we'll have a common module, and this is our Kotlin Multiplatform module, and it uses a plugin, multi-platform plugin, and we're also using things like Kotlin serialization and SQLite and so forth, and also another plugin which I definitely recommend using if you do decide to sort of go down this path and explore it in more detail is CocoaPods, which gives you sort of mechanism to very nicely integrate this sort of the building of the Gradle module in your Xcode project and the pulling in of the resultant framework that gets built when using Kotlin Native in your iOS and macOS projects, for example. So just a few, I'm not going to go into too much detail here, but a few things just in this multi-platform module. We have a few targets. Obviously, we have iOS, watchOS, macOS, Android, JVM. We're going to look at a few of those today. And the other thing worth noting is then for each of these targets, what a Kotlin multi-platform library, when supporting Kotlin multi-platform, will basically provide implementations, dependencies then for the various platforms. So, you know, here we have Kotlin, coroutines, Ktor, serialization, SQLite, and actually up to just as of a week ago, or less than a week ago, the first alpha version of Coin. I don't know if people have used Coin dependency injection framework on Android. It's now available in the multi-platform world now as well. And then you get sort of Android-specific versions of those, JVM and so forth. And then within your multi-platform module, your source then is going to exist in a number of trees here, a number of source trees. Hopefully, you know, the idea is that most of your code is going to exist in the common module. But what Kotlin Multiplatform supports then is the ability, and we'll see some examples of that, where I can kind of override effectively. I can provide platform-specific implementations for various things. I mentioned about SQL Delight for persistence. The database driver is platform specific, so I can kind of almost delegate out. Kotlin Multiplatform has this concept of expect an actual. I can expect a method to create the DB, and then in my various platform implementation or platform specific source, I can provide an implementation for that. But my common code then works on the basis of that sort of expectation that will be made available. Okay, so enough talking. Let's write some code. So our very basic application here, we have common, we're going to write a very basic remote API class, which represents our request to Cater to get this data back. A repository, which at least starting off initially would sort of really just wrap around that, and we'll hopefully get a chance to add some persistence to that. And you know, in the Android world, we're going to write a very basic view model and an activity then, which contains our Compose UI code. And then we'll switch over to iOS and Android and see how we can sort of start utilizing this repository class directly from that code. So our API, you know, this is the endpoint that we're hitting. And so what I'm going to do, you know, to save you watching me mistype a lot of stuff, I'm going to very actively use Android Studio Live templates and Xcode code snippets, for example, to sort of pull in pieces of code, but hopefully do it in such a way that sort of illustrates various points in terms of what we're trying to do. So the first thing I'm going to do is, the first sort of live template here is our data classes. So these are our Kotlin data classes that are going to map to the data we're getting back over Cater from this remote endpoint. And we're using the serialization, which is provided, this annotation, which is provided by the Kotlin X serialization library. So if you're primarily working on Android, you're probably more familiar with maybe using JSON, and you're probably using it along with RedHat, for example. And you know, these can be mixed and matched, by the way. You don't have to specifically, I mean, RedHat doesn't work right now on multi-platform, and I'm not sure if it will at some point, but at least in the multi-platform world, the sort of the key library, the key that has the support is Cater. And we're going to write a very basic class which encapsulates our request to this endpoint. So first thing we'll do is so this is the HTTP client object which Cater provides, and sort of uses this DSL type approach. If you use Cater for your backend routes endpoint, you know, you're probably familiar with seeing that approach to the way it declares the routes that it supports. For a similar way here, we declare that we're supporting this JSON feature, which is going to specify that we're using this Kotlin X serialization library. And that's going to be responsible for, you know, out of the box for serializing, deserializing our JSON objects back and forth to our data classes. And we're adding logging as well, which we'll see is, you know, is useful obviously as when we run this on different platforms. We can see, just get some sort of feedback that we've that the request has been made and so forth. Let's add a URL, which is the URL, and for now we're going to write a very basic suspend function, which this is why I shouldn't be typing. Fetch people, which is going to be use client.get. We're going to return an Astro results type. Okay, and that right now is and this actually just return the people element within that. So the data we get back from the endpoint is going to contain a list of people, and for now we're just going to return the list of people back from this endpoint. So this is, you know, I said I was probably going to overuse this term, but this is our minimal implementation. You know, typically obviously you'd have more error checking here, and I'm conveniently going to skip over that today. And then our repository right now, so our repository is, right, initially at least, is going to make use of this people space API that we just wrote. And the first thing to note here is that we're instantiating this directly in, I mentioned that as of less than a week ago, the first alpha version of Coin was released, which supports multi-platform. In the version that's in the repo, we're actually using Coin, and we're actually injecting this as a dependency, which is obviously preferable than instantiating directly like this. But at least in this example here, and sorry, we're going to write it. We're going to write a kind of an analogous fetch people API method here, which is going to say people space API dot fetch people. Okay, so this is even more minimal repository class, and we'll build this out a little bit over the course of the talk. So now we have our API, we have our remote API, we have our repository. Now I'm actually going to switch over to an Android unit test here, sort of something pre-prepared earlier. And we're going to just run that as a sort of a validation that what we've built so far is going to plumb together correctly and runs in. I'm also going to just use it as a sort of a hook to mention something else as well, which is we're running this as Android tests run, they're running in the JVM. And we're testing code that's in our common multi-platform module, but because it's JVM, it's actually using the JVM dependencies from there, which is kind of interesting. So even though you wouldn't typically obviously make an API request as part of your unit test, but you have the ability then in any of these libraries to run. And there's, particularly around SQLite, there was a very good talk at DroidCon last year on SQLite, and he talks about the power of being able to sort of run his database tests, unit tests, using sort of the JVM implementation of SQLite. And here we can see our unit test. We just validate that we make the request. Here's our JSON that we get back, and here's our the data classes that map to that. Okay, so that's our common code written, or what we have so far anyway. So now let's start with the Android side of things, and again, sort of some pre-prepared code here. If you're an Android developer, you're probably more likely familiar with the Android view models and part of the Android architecture components. And what you get here, for example, for free, so to speak, is you get an implicit view model scope, which is sort of lifecycle aware and use the likes of live data and so forth. So because we have this scope, we can call this a suspend function. We're just going to call the repository.fetch people. And in the app module here, as I said, in the repo on GitHub, we're using Coin for both the app module and the shared code. But in this particular version here, we're using Coin just for managing dependencies within the app module. So we have our view model. Coin has very nice support for sort of built-in support for view model. This kind of first-class support for the concept of view model. And we have this people in space repository, which is our class from our common code, which is being injected into the view model. And then very basic implementation, on startup, we're going to call this a suspend function, which is going to fetch the data, just a one shot, right now at least. Okay, so that's our view model. And finally, for our Android side of things, we're going to write our UI code. And this is the point where in a normal Android application today, we would typically have an activity, we'd have maybe multiple fragments, we'd have layout files, for example. For something like this, where you're using a list, you'd have a recycler view adapter, you'd have a layout file for your individual elements within the list. What we want to see here is with the use of Compose, that you get a sort of much more natural, fluent, I suppose is described as natural, fluent approach to UI development. So let's start with adding something that represents our. We said we're going to have a table of people in space, so each row in the table is going to be represented by this person view. And when you're using Jetpack Compose, your UI is declared as I was kind of mentioned earlier, as a set of kind of composable functions. Normal Kotlin functions which have this composable annotation. Excuse me. And in this case here, where we have a row, we add some padding to it, we have a text element, and the text element has name and craft. And one of the nice things that Compose has, as SwiftUI has, is that you can, as you're building out your UI, you have a preview capability where you can actually sort of preview the, which is glitching on me a little bit for some reason. A preview capability that would normally work here, that allows you to, as you try out your code, you can make changes to it and see the effect of it straight away. There we go. Okay, so there's our very fancy UI here, and this is based on this preview annotation, which is declaring that I want to show a single person view element with this particular data. And you can obviously get more sophisticated with mock data, showing a full list, for example, and so forth. But our person view is, as I said, is representing an individual line in a table, in a list. And our main layout then is going to be the function that represents our overall UI. And in this case here, we're using Compose's adapter list. And again, I made that comparison again because I think it's an interesting one. If you're familiar with using recycler view on Android and all the associated plumbing that's required for that, this is simply all that's required in Compose. We adapt our list, we pass it the list of data we want to iterate over, and then for each element in there, each person in the list, we pass it down. we're passing it this state element, and I'm going to just talk about that in a moment. But this is the key thing about Compose. It's the concept of sort of declaring what your UI should look like in a particular state, and the idea is that any state changes then should cause recomposition. The appropriate areas of your UI to be recomposed, to be re-rendered accordingly. So in our main activity, then normally you would say content here. You pass in a layout file. Here we're using just passing in. We're just going to call it main layout, and we're going to pass in people state. And people state is if we switch back to our view model for a moment. Again, if you're familiar with Android, you probably if you're using standard Android architecture components, you're using live data and you're sort of observing the live data in your UI and updating the UI accordingly. In this particular case, we're using an extension function that Compose provides, which allows us to map that observable data to that state. And then we can pass that state in. And whenever that changes, then the UI is rendered. So without further ado, let's run that. Sorry, still running my unit test here. Go back to app. And I'm using Android 4.1 Canary. I mentioned that you have to use that if you want to use Compose right now. But having said that, the nice thing that the 4.1 Canary has right now is that it has a built-in emulator sort of in a window. This is sort of relatively recent in one of the relatively recent Canary releases. Sorry. Okay. Start this. Again, it would be. Let's see. Sorry. Bear with me for a second. Okay, here we go. Okay. I'm using a little bit of product placement advertising. I'm using a neat bar here, which is actually Android based, and I almost actually ran this on the neat bar, so that was kind of interesting what would have happened there. Sorry. So having done that, we have our super cool UI here. Okay, we're not going to get any UX awards today. Okay, but hopefully illustrates. And let me just zoom in here a little bit. We have a basic list of elements coming from. Just sort of I'll make a few changes here to sort of demonstrate some of what we can do with Compose. But just to sort of recap a little bit, we added a remote API endpoint which retrieves data using Ktor from a remote endpoint, wrapped in a very basic repository right now. That in turn is used from our view model, which has this live data. I'm going to make another sort of tangential reference here. Actually, is I know if you follow sort of the development of sort of recent Kotlin X core teams releases, there's been I think in the 1.3.6 release, there's this concept of state flow, which is interesting, which is seen as kind of mapping to and potentially replacing live data. So it'll be very interesting to see how that kind of develops out, and that has more. I think the more that I guess you can depend on the language in general and not depend on libraries, I think the better. But and then in our UI, we have this list, which represents the list of data that we're getting back. So we'll make a couple of changes here just to sort of make it a little bit better. So we'll add an app bar, and this if we run that then, and as I say, it's quite nice, as I mentioned, just having the emulator running in a window here in Android Studio, and you're not having to sort of switch back and forth. Sort of that the sort of lack of the need not to have to do that context switching is kind of is pretty powerful, very useful. So we've added an app bar here. We'll maybe make our what I column here would make our UI for our list here a little bit. So this is where you do have to unfortunately watch me type a little bit. Keep it to a minimum. So we are going to just have the name and craft sort of on top of each other in each row, and we're maybe going to style it a little bit differently. We're going to say and say font, we'll change the font size. We could say 20 SP, for example. And in the case of this one here, we'll maybe 16 SP, for example. And so I should be building that now. Okay, it looks marginally better. You know, and hopefully I'm not going to go too much. I mentioned that Brian Gardner talk, he goes into a lot more detail in the case of sort of a Gmail type application, but hopefully, you know, from this you get a sense of what a declarative UI framework, the capabilities it provides and the approach that it espouses, I guess. So at least, you know, I haven't dug very deeply into it, but at least from what I've done with this, and you'll see that, you know, this is the other interesting thing. When we start doing this with SwiftUI, we'll start to see that even though the terminology, or not even the terminology, but the syntax is a little bit different, we're still fundamentally taking the same approach. And getting back to that earlier point about alignment on Android and iOS, and these are the areas I think where, you know, I think it's going to be more interesting going forward in terms of seeing where some of these, you know, your approach to developing on Android and iOS, and how some, in terms of similar alignment in terms of architecture, maybe when we start using declarative UI frameworks on both of those, the code is certainly a lot more approachable. I mean, I started looking at this in when this came out in SwiftUI, and I think like any Android developer who sort of very infrequently fires up Xcode, you know, struggle with storyboards and figuring out view controllers and table views and so forth. And you know, when we'll see this similar code in our iOS project in a little while in our Mac, and you just see how approachable it is. And you know, you imagine vice versa. You know, for an iOS developer coming into the world of recycler views and so forth, it's kind of quite cryptic. Okay, so how are we doing for time? We have our Android application. Let's switch over and do something for iOS. And this is where. So I'm going to mention a couple of things, I guess, which are the world of Kotlin Multiplatform is sort of ever changing, and the world of Kotlin in general. You know, we're close to a 1.4 release, a fairly major release of Kotlin, and but particularly with Kotlin Multiplatform, there's a lot of sort of balls in the air, and they're starting to fall. Like when I started looking into Kotlin Multiplatform, it was problematic getting the dependencies set up together, getting everything lined up. More and more, we're seeing those things coming together now. But right now, as things stand, I can't call suspend functions from iOS, as you probably imagine. But with the 1.4 release, and in fact the 1.4 milestone 2 release, which is due out imminently, I think, that will actually include the initial support for at least generating a wrapper. So we can effectively call suspend functions from iOS, which will make this a lot cleaner. But in the meantime, what we typically have to do is do something like this. We have to add an overloaded version of the method, which passes in a success handler, or, you know, if you're being a bit more robust, an error handler as well. And then, you know, we're going to use some scope that we've defined in our multi-platform module here, and I'll talk about that in a moment, and call the existing method, and then just pass that to the success handler. But hopefully, you know, in next few weeks, days or weeks maybe, we'll have the capability to call suspend functions from iOS, which is pretty powerful. Okay, so we have at least now a method where we can call from our iOS code. So let's switch over to iOS. I've obviously haven't gone into detail in terms of how everything's hooked together. I mentioned there's a CocoaPods plugin, and it is actually relatively straightforward to use, and it sets up the sort of the plumbing in place so that when I hit run here, it'll automatically build and run the Gradle module with the appropriate target, and the resultant framework will be used in the Xcode project. So, our iOS client is going to take a very similar approach to our Android client, and we're going to use we're going to define what I describe as a view model here, at least. And this is when we sort of scratch a little bit below the surface, we'll see something that's actually quite similar to our Android view model. You know, this concept of observability. We have this people, which are, you know, similar to our live data in our Android view model. We have this observable. We're using this iOS's combined sort of reactive framework. Similar to our Android view model, we're passing in this dependency, which is our people in space repository, and this is the same repository class. You know, when we talk about, if you know, I'm importing common here, so this is having built the Gradle target and created a framework that's being used in iOS. We now have access to the common code. and we can use it directly, which is pretty powerful. So we're going to use the person class, and we're going to use the people in space repository class, and these are the direct classes that we created in our common code and that we used in our Android project. And similar, very basic approach like we did on Android. On startup, we're going to make a request, and we're going to call fetch people, and any observers of this data then are going to get notified of that. Now, if we look in our Swift code, instead of an activity here, we have this content view, and instead of the person view with the that we saw with the composable function on Android, the SwiftUI approach is this concept of a struct. But what we're effectively saying is something very similar to if we scratch below the surface a little bit. Instead of using a sort of a Kotlin function, we're using a Swift struct. We're passing in this person object as we did on Android, and we have a specific body element here. But we're using things like hstack and vstack, which map to our row and column, for example, in Compose. We have text elements very similar to text elements that we had on Compose, and we can add styling. And just sort of a note here, which is kind of interesting. I mentioned that Compose was releasing quite frequently, and frequently with breaking changes as well along the way. And if you followed the progress of Compose, you might have seen they had this sort of @model annotation. Very soon after introducing it, they've actually deprecated it. And I thought it was interesting, the reason that, again, if you follow later Richardson, he kind of tweeted about this. And the reason they did that was to ensure that they had closer alignment with React and SwiftUI, which I think was very positive to see. The more we sort of, something we probably wouldn't have seen in the past, but the more we can see that sort of alignment, again, that sort of alignment across your Android and iOS development becomes easier. As a Swift developer, as a Kotlin developer, I can kind of easily come back and forth between these projects, and the code is very readable and very approachable. And then in our body here, we're going to add in a list view. So instead of our adapter list that we had on Compose, we have a list, and in a very similar way, we're observing our view model here. We're observing the data, and anytime that's updated, this will get updated, and it will render the list. And sorry, my stop share button is overlapping the run button on Xcode. Sorry, a second. It's not actually, sorry, it's over here. Okay, fingers crossed, let's run this. And just to mention while it's running, so what's actually happening under the hood here is that it's building the Gradle module, it's building the common module. And that's something, depending on your cadence and depending on what's changing, shouldn't happen very frequently. If you're an iOS developer who's focused on UI development, you're using some pre-existing code, that's going to happen once, and then you work within Xcode like you normally use, and the build time is as you would normally expect it to be. But now I have all this non-UI capabilities available to me through normal API requests. Okay. And hopefully what we should also see in the debug window here, if everything works correctly, is we should see that Ktor logging showing the request being made. Okay, a little bit slow to start up, and here we go. Okay, great. So there's our Ktor request. That's running that common code that we saw in a common repository. It's logging out the Ktor request and response, getting that data back from the repository through the iOS view model, and it's being rendered in a equally impressive UI in our iOS client. And let me just switch over quickly to our Mac project. And in our Mac project, we are in fact going to use the exact same view model. We're going to use the exact same SwiftUI, and this is sort of, I kind of touched on this earlier, but almost orthogonal to the discussion I said about Kotlin Multiplatform is this power we have that exists now in terms of using Swift and using SwiftUI across all the Apple products. And touching on iOS and macOS today, I mentioned somebody had contributed a watchOS implementation and a tvOS implementation somebody's working on as well. And obviously, what you would do using a Mac client in terms of the larger screen estate to work in, your UI is going to be different. In fact, the version of this project in GitHub, I've added an additional endpoint which gets the actual position of the International Space Station, which changes periodically. We can pull for that. And in our Mac client, it shows a UI and renders the position of the space station on the UI. So we're sort of taking advantage of the extra screen real estate that we have available on Mac. If I But just for demonstration purposes here, I'm using the sort of exact same sort of SwiftUI model. I'm using the exact same SwiftUI code. And if I run this here, and this again is going to sort of under the hood, it's going to build the Kotlin module. This time it's using a different target. Obviously, it's targeting macOS. So this is why we're building, again, in this case, we're building a binary that is that can be pulled in and used in the Xcode project. So similarly to our iOS client a moment ago, we should hopefully see this starting up, and we should see again the Ktor request being made. Here we go. Okay, great. So there's our Mac client. So just to sort of recap very quickly, we have, you know, in a fairly minimal project here, built out sort of the structure to support retrieving data from a remote endpoint, wrapping that in a sort of minimal repository, making that available on multiple platforms, and then consuming that in a way that actually quite aligns quite nicely across the different platforms. The code, as I keep saying, is minimal, and the implementation is minimal, but the structure that we have there it scales, you know, beyond obviously that. I mean, once you have that in place, you can obviously drill down. You can put more sophisticated UI. You can add additional API endpoints. You can build out your business logic. Your repository implementation will get more sophisticated depending on how you want to sync, how you want to manage offline data, and so forth. But at least hopefully you get a sense of you know, what the sort of capabilities provide, albeit in a very basic application. But just to touch on a couple of other points, if we go back to our shared code, I mentioned, so you might notice I'm using this Ktor scope. And another sort of capability within the Kotlin Multiplatform ecosystem is this concept of expect actual. And there's a number of places where ideally we write all our code in our common code module, but there's a few touch points where we want to go out and provide platform-specific implementations. One example is SQLite, where the way we create the database is platform dependent. But this is actually, I've added this here actually as a workaround right now. I mentioned that we're using the multi-threaded, the native MT version of Kotlin coroutines, which is not officially released yet. And the release version of Ktor doesn't work with that on Mac. It works well with it on other platforms, but on Mac it doesn't for some reason. But the workaround for that is to use run blocking. It's sort of an ugly workaround for now. But by using this Ktor scope and by using expect, if you look at the actual implementations then on the different platforms, in Android we're using, you know, even though we shouldn't really be using global scope here, but using global scope, we're launching on the main dispatcher. On macOS, we're using run blocking. And it's I think it's a nice example of that capability, you know, in terms of it. And there's a range of different things that you can obviously would use to that for, in terms of things that are the way you manage settings, for example, varies from platform to platform. You might have your own implementations of that. So I touched on persistence. Here's an example here. For example, we have createDB in our expect, in our common module. We say we expect this function to exist called createDB, and then on Android we're going to use the Android SQLite driver, whereas on iOS we're going to use the native SQLite driver, Kotlin native version. So a few touch points at that. The way that there's something kind of similar in Ktor. I'll go back here. You can pass in the specific HTTP client engine to use here, but Ktor does something quite nice. Based on the dependencies that you've added for your platform, it will pick up the appropriate ones. It will use sort of OKHTTP for Android, it'll use for NSURL session for iOS, and I'll do that automatically based on sort of class path and what's been set up as a dependency for those particular platforms. So I can use HTTP client as I'm using here. So I'm going to, as a repository as it is here right now, it doesn't serve much purpose, you know, other than just sort of simply wrapping the remote API requests. So let's just, I'm just going to add in a block of code here, which is our database code, and I'll talk through it a little bit. So I mentioned that we're using SQLite, and SQLite is a multi-platform library that takes a sort of somewhat different approaches. If you're used to using Room, for example, on Android or other ORM approaches, it takes a sort of much more, I guess we call it low-level approach. You define your SQL and you define the API names effectively that map to those. And I mentioned in the sort of the Gradle, the build Gradle file for our project, we're using SQLite plugin that automatically generates then a set of queries based on this. And then in our repository class, then we're calling out to our createDB that we mentioned a moment ago, and we're using these automatically generated queries. And now we can do things like, in this particular example, we're going to fetch and store the people into our database. So we're going to make a request to our Remote API. Again, this is, in your own particular use case, different apps have different approaches to how they synchronize data, how you manage offline and so forth. We're taking a very crude approach here. When we get the data back from our endpoint, we're deleting the table, entries in the table, and we're writing the fresh data into those. And then what we can then do then is we can, SQLite supports Kotlin Flow, for example. So we can write a query here, which, whereas before, in terms of making, the code we had which made a request was kind of a one-shot. We just got data back and we showed it. A more typical pattern, obviously, is that you would have some data coming from a back end, either through polling periodically, perhaps, or using WebSockets. That was so you would have, WebSocket or something. You would have some data coming back from a back end, maybe push notifications. That gets pushed into your database, and your UI is typically driven from, you have one source of truth, for example, and that's your database. And here we have the beginnings of that sort of approach here. We fetch the data from a database at the beginning, and we now have this fetch people as flow, which is using our generated query, and it's mapping to a Kotlin flow. Having done that, we can then go back into our view model, for example. And instead of having this kind of one-shot approach, we'll use collect. And now we have our mutable live, our live data. Then obviously we're going to update that anytime. Anytime there's changes to the database, we'll get get called back here in our collect, and that gets reflected obviously in the UI then. And similarly then in our we do something very similar then in our iOS client here. We're still sort of using that callback approach, but rather than using fetch people, we use fetch people as flow, and then again any data that changes in the database then gets called back and is reflected accordingly. So doing okay for time. So that sort of covers the basis in terms of, we've seen iOS, macOS, Android. Just to mention, if you are putting this repository down from GitHub, there's a couple of more modules that are here. There's a backend module which has a very basic Ktor server here, which I had sort of set up. I was sort of fearful that the remote endpoint would stop working for me during this talk. So I actually have a here somewhere. I have a backend implementation. That backend module is running here in the background, sort of serving up dummy data if needed. But we're using, and this is using the Kotlin JVM, and we're using sort of people in space API. This is sort of really acting as a proxy in this particular example. Using the same shared code, the same data model and so forth. And if I go, there's a sort of very basic example then of a Kotlin JS here. And here we're using Kotlin JS with the set of Kotlin React wrappers. If you're used to using React for your web clients, provides a sort of set of wrappers that sort of map to some of the, sort of the React capabilities. And we can, even though there's got syntax errors here, but you can, in a similar way, we're sort of retrieving our list of people from the same endpoint and rendering that in a HTML. And I think that's it. If anyone has any questions.
Awesome. That was brilliant, John. Thanks very much. Really enjoyed that. I've seen a good few presentations on Kotlin Multiplatform, but I think I understand it a lot better after this one than any others. So yeah, really great. Great intro, and I think the super simple API just kind of makes the other moving parts easier to understand. So yeah, a couple of questions on the chat. So did you experiment with other architecture designs like MVI or MVU in order to achieve higher code sharing ratio? E.g., view model looks very similar to me.
Yeah, it's an excellent question, because it sort of talks to, I think, one of the key strengths of Kotlin Multiplatform is that it doesn't force you to take a particular approach. The more you can align your architecture across Android and iOS, I think there's some benefits there, but there's nothing that forces you to do it. And the more you can align your architecture, also that affects how high up the stack you can target in your shared code. So there's quite a few examples. If you look out in sort of multi-platform samples out there, and there's some excellent samples out there at the moment, you can see a number of ones which actually put the view model into the shared code. There's actually I've been meaning to try it. There's a library that provides MVVM and actually uses the Android view model when running on Android and uses a sort of abstraction running on iOS. Which is very interesting. I've seen a few MVP examples where the presenters in the shared code, for example, not to stop you from using MVI. A lot of the examples I see these days of MVI is still using the sort of Android view model under the hood, so to speak, and you starting to use things like Flow for your intents and so forth. So no, that's, to be honest, like I said, is one of the key benefits. From a risk management perspective, I think Kevin Galligan, as I mentioned before, he kind of articulates this probably better than I could. But if you compare it to other sort of cross-platform, multi-platform solutions, that is the key benefit for me, is that you can start to use it in a very small way, and then sort of you have the flexibility then to use different approaches depending on your own needs.
Cool. Thank you. Question from Eugene: Why do we need callback success for iOS?
Okay, so that's hopefully something that's going to change very soon. Right now, as things stand today, you can't call so we end up having to provide this kind of a wrapper where you pass in a closure from iOS or a Lambda into your and then sort of delegate into. Literally, I think it was described as being imminent. The 1.4 milestone 2 release of Kotlin has now got. To be honest, I haven't looked into it too deeply. I'm not too sure exactly how it would manifest itself, but what I understand is it effectively generates a wrapper that you can call from iOS, which allows you to call suspend functions. There's got open questions around, what dispatcher does it use, what thread does it run on, so forth like that. That I guess would be interesting to see how that kind of works. But I guess answering the question, hopefully very soon we won't have to do that. We'll have a single API surface more or less from your repository, or whatever your layer is that you expose from your shared code.
Yeah, cool. Georgios says, Dan, Kotlin Multiplatform is great. Thanks for the presentation. So yeah, definitely agree with that. Question from Ian: How would you convince iOS developers to adopt Kotlin Multiplatform approach? I think this is kind of a key topic, and vice versa. But you mentioned that there was some collaboration on keeping the declarative UI framework similar.
Yeah, well, I don't necessarily collaboration, but at least sort of, I guess, foresight and awareness from the perspective of the people doing Compose. Compose is a little bit behind. SwiftUI is sort of production ready right now and using. Compose is still very much in development, and I was very encouraged, as I said, to see that kind of note from when we sort of made people working on Compose, that they were keeping in mind that compatibility. And even, you probably hopefully saw there in that example, even so, the approach is very similar. The terms VStack versus column, HStack versus, but at least the way state is managed and the way, the key part of this concept, I suppose, is that we're declaring what our UI should look like in a particular state. And it sounds like the approach to that will be somewhat aligned, at least. And answering the sort of trying to answer the harder question, the broader question in terms of, and that's the thing that comes up. I mean, if to be honest, it's probably mostly Android developers like us, who are probably exploring it for the first time. And I think there's a broader kind of question about how there's organizational elements, as there always is. Like in a previous company I worked on. As an Android developer myself and the iOS developer, we were typically working on the same feature in the same Scrum at the same time, and we would work closely together. So there's that kind of alignment that you need to kind of get in place anyway, I think, and there's benefits from that. Taking aside sort of the technical aspects, but then as you start to get the fact, fast forward, if you were to ask this question a couple of years ago, where maybe Objective-C was primary language on iOS and Java on Android, I think it would be different. Kotlin and Swift are remarkably similar. If you've looked at one, you can very easily understand the other. And the fact that your shared code is almost by definition non-platform specific. It's going to be business logic, it's going to be API. There's some knowledge about the client libraries that you're using and so forth. It's at least readable. It's at least very readable by but yeah, it's clearly not an easy one to answer. I think you're going to. I think a big selling point. I think I touched on this earlier. I guess was that it isn't targeting UI code. You know, you're targeting shared logic, and as an iOS developer, you're still free to use the best of breed tools and libraries to ultimately what we want to do on mobile platforms, particularly is we want to build a compelling user experience. You know, and as we know, there's a lot of heavy lifting that goes into that, independent of some of the business logic and some of the API logic and so forth. So having a common code like this doesn't force an Android UI developer to do anything differently. Potentially, they now have this repository API available to them, which is to return some data, and how they render that, the tools that they use, the reactive frameworks. Like, you know, it kind of touches on the earlier question to some extent about how high up the stack and whether you put your view models in common code. I've tended to favor sort of, at least selfishly as an Android developer, continuing to use the Android view model in the Android code, because the Android view model has a lot of value add in the Android world. You know, it has this view model scope, it has saved instance and state management, the way you manage navigation graphs, for example. Likewise, as an iOS developer, I probably want to use Combine. I want to use sort of best of breed sort of technologies available to me. So there's a line there. You know, you can be overly ambitious, I think, in sort of targeting too high up in the stack with your shared code. Whereas I think it's a pragmatic approach where you sort of target a little bit lower, get the benefit from common business logic, common API logic, but allow the iOS developer and Android developers to use the best tools that they want to use them for developing a compelling user experience.
Okay. Cool. From Georgios, great talk. Thank you. Another one from Eugene. Where Coin instantiate in iOS? Yeah,
it's let's see. Do I have an example of that here? Actually, I'm going to sort of go back over to. So I have a set of very in line with the project. I have a line of very minimal blog articles on different points, and I'll just switch it to this one here because it gives you an example. So in the case of iOS, so what we do in our common module is we expose an initialization method, and then we call that from the appropriate hook on iOS, the appropriate application lifecycle. So by calling, in this example here, by calling this init coin in our in this function in iOS, that causes the appropriate coin modules to be configured and hooked up, so that when we then go into our people in space repository, as we have here, we can use sort of coin dependencies, and they get injected automatically.
So it's on mute. So can you explain better the flow mechanism that allow changes to DB to be automatically reflected in the UI?
Sure. So part of this, I suppose, is a credit to, and it's, I suppose it's not, if you're using Room on Android, I believe it maybe has or about to have, I'm not too sure. I haven't been using Room in a while, but I don't know whether it has flow support. I think it has, but it certainly has sort of live data support. And a key part of any sort of persistent library is APIs that allow you to get notified when there's updates. So, fundamental sort of capability in any of these libraries. So the SQL, sorry, if I can go back here. I closed the common module here, sorry. Too many modules here. Common, sorry, let me just go back down, drill down here a moment. So we're using, let me just minimize this. We're using this generated query that SQL Delight provides, but it also provides this as flow mechanism. And if you've used, I'm not too sure how much people have used flow. Sort of people who've sort of gone on the path to start to use Kotlin. I suppose there's a sort of a set of incremental capabilities. I suppose we started using Kotlin. We obviously started to use coroutines for sort of like one-shot kind of requests. And I guess flow is sort of relatively recent. It's kind of development. I suppose it's still experimental, but flow gives, like what's the example if you're used to RxJava is sort of your single versus observable for sort of, at least for sort of cold streams, that you can get, single as a single result of a kind of remote API request, for example, whereas, observable is something that's going to be going to potentially change. So using the SQL library like we're using here, and like I said, Room, I think on Android, if you're using it in the Android specifically, would provide the same capability, provides this as flow. And then when we call, what corresponds to that then as a consumer of a flow is this collect, we can call collect. And collect is like sort of, again, if you're using Java, you're sort of, observing the data coming back, you're subscribing, I guess. This syntax, this mechanism will mean that anytime the database changes, our code here that's calling collect will automatically get notified. And, here then we're hooking into a slightly different world. We're using sort of live data. We're updating the live data, and anything that's observed in the live data then obviously will get updated and we'll update the UI. In our example here, we're using Compose, and we have a sort of an extension method that kind of maps to that live data, but the same underlying principle at play. If that answers the question.
Cool. Another one from Georgios. Do you have to follow mono repo approach for all targeting multi-platforms, or can you publish artifacts for other platforms to use?
Yeah, it's an interesting question. I think it would encourage a mono repo approach, at least my opinion. I don't think you could get around that. I mean, you can use sort of some modules. You can use potentially. The question about whether you publish the artifacts is an interesting one. I mean, it talks to a sort of more process question, organizational question. If there might be some views that maybe it's more palatable as an iOS developer if this is just an artifact that's published and consumed. Taking a broader view, I've sort of, like many of us, we worked on sort of projects in the past, mobile projects where we've had shared C++ code, for example, running on Android and iOS, and there's always that, even worse in that case, to be honest, where we have the question mark of, who manages that code, who maintains it, who can change that code, and so forth. I think, part of the benefit of this kind of fact that we have Kotlin and Swift is that the common code is very approachable. Now, it does ask the question, okay, as an iOS developer using Xcode, maybe I don't ideally want to switch to Android Studio. I don't want to use IntelliJ. I should mention, touched on TouchLab. TouchLab have a couple of Xcode plugins in the works, and one of them allows you to actually view and change your Kotlin code and get all the syntax highlighted within Xcode. If you're in the JetBrains world, the sort of app code, which is kind of interesting. Again, I don't think necessarily iOS developers kind of moved en masse to that. I think they're still obviously would prefer to use Xcode. But I'm very curious to see how that sort of builds out. And when you have the likes of app code from JetBrains and you're using that to develop your iOS code, then I think the sort of the need and the ability to sort of switch context becomes a little bit easier. But at least with sort of maybe super plugins in Xcode, as an iOS developer, I have a repository and it's maybe returning certain data type, maybe not returning some elements. I just want to simply go in there and make a change, add another element. It should be easy to do. But I think it's definitely a broader question. How do you want to manage that? I would prefer if there was an approach in place where that code was buildable and editable and viewable by iOS developers.
I guess on that same thread, does iOS code generally use Gradle, or what's the iOS equivalent of Gradle?
I mean, typically you're using Xcode. I'm far from an iOS expert now. I mean, I've really only dabbled with building projects. I mean, typically, the mechanism is quite certainly very different anyway. What's happening under the hood, as I mentioned, with the CocoaPods plugin is that it generates a pod which has the effect then it's kind of configured to automatically run the Gradle target when you build and make changes. So it's just to a large extent sort of transparent or hidden, I guess. It's kind of contradiction from an iOS developer that's happening under the hood.
Okay, cool. One question only: why not to use KMP?
Why not to use KMP? That's a good question. What would be the disadvantages? I mean, I think it's still not fully mature. If you follow KMP discussions on Twitter, and again, you'll see the likes of Kevin Galligan and those, and this particular question comes up frequently: is it production ready? And I think TouchLab and Kevin sort of answer that in a kind of a roundabout way a little bit. In terms of it depends. It depends on your use case. And similarly, it depends on your use case. As I mentioned earlier, ideally you're starting this small. You're pulling it in for some maybe small element of your application. This is a sort of initial trial. I think you can definitely do that in such a way that doesn't impact too much on sort of the development process for your developers in general. But it gives you the sort of capability then to sort of build that out then and sort of start to gradually add more capability, more business logic, more API requests and so forth.
Yeah, agreed. It seems to be really starting to prove itself. But yeah, some big apps using it, like the Square Cash app, which I saw today. Jake Wharton has
he's back
on that team, so that can only be good news for
No, definitely, and it's sort of, I've been looking at it, I suppose, since the start of last year, and it's been a relatively, it sort of has depended a little bit on some stuff being built out, obviously, and prioritized by JetBrains. One of the things that Tom, you were at the Kotlin Conf last year, and the keynote there, I think it was very clearly stated that they saw that multi-platform as a priority, maybe in a way that they didn't necessarily see it before. So in terms of some of that, the work being done in Kotlin Native, the example I gave where you're going to be able to call suspend functions from iOS, more and more stuff being done by that, I think it's just building up a momentum now at the moment in terms of the capability in general, and I think also JetBrains' commitment to it and it's sort of advocating for it, I think, is going to sort of just ramp up.
Okay, cool, awesome. I have a curiosity regarding Jetpack Compose. Jetpack Compose has compatibility with all the component architecture. Thanks very much. And consult, will the web editor be uploaded? Yes, it will be uploaded. So yeah, I guess it's about Jetpack Compose compatibility with the architecture components.
Yeah, it's very much a TBD. Right now they're adding extension functions for, as we saw today, being able to observe mutable live data, and that gets mapped to the sort of the state object that Jetpack Compose expects. And they've added other ones to for flow as well. For example, if you start taking that approach, there's also another level of compatibility there, I suppose, is that maybe you have existing layouts, you have existing views, and it has kind of come and go. I mentioned that each release sort of breaks something. I think something came in and kind of went out again in a subsequent release, was a way to sort of very easily just kind of have a compose element which is maps to a sort of legacy, so to speak, view. As you're migrating and you have a kind of a custom view that does a particular thing, you can start. And I think that capability will have to be there. That's starting off, that I can sort of pull that in as part of my Compose UI.
Okay. Cool. Question or two of my own. So yeah, the Compose Jetpack Compose stuff was really nice not to see any XML, which was pretty beautiful. So in December at Kotlin Conf, the Compose team were under strict orders to not mention any dates for any release. Have they mentioned any dates?
No, they're very good at that. I see people pestering Leland Richardson a lot, and he was on a fragmented podcast last year, and he was on another one recently where, and I think the guys kind of pushed him frequently throughout the talk, and he gave away nothing. I mean, I think hopefully, I mean, I think the fact that SwiftUI has, the adoption has increased so much, and it's being used in production applications. I don't know. I don't know if that's being seen as necessarily pressure, but the hope is that it will start. And I definitely haven't used it a little bit, and seen sort of SwiftUI and seen sort of the benefit of that. I hope at least that will become the sort of standard mechanism for sort of UI development on Android, as I think SwiftUI is on iOS.
Cool. Yeah, enjoyed the product placement of the neat devices. I know you've mentioned to me before that you have iOS and Android offerings. So I'm not sure.
Yeah, we don't. We have an iOS developer on the team. Actually, sorry, just a slight tangent there is kind of interesting. We have an iOS developer that I worked in the past in the team, and he's coming from, just in terms of talking about Kotlin a little bit, he's coming from a Swift background, and as a Java developer, I've sort of been somewhat slow to sort of pick up some of the Kotlin idioms, and he's actually been faster to do that, because actually some of the idioms map relatively closer to sort of ones in Swift. So it's interesting in terms of that crossover, like I mentioned earlier, that as a Swift developer, he's taken to Kotlin very easily and using it probably better than I am right now.
Okay, so your TVs are all Android, but you can have an iPad controller for them, is it?
So Zoom supports. So we have the neat bar, which is what I'm using here for calling into this, and so definitely some product placement. The neat pads. These are running Android, and they connect to an existing sort of TV and so forth. The Zoom Rooms offerings right now that do support, Zoom have themselves iOS clients, for example, that can act as controllers. It's not something we specifically work with.
Okay, cool. So yeah, I guess I was trying to tee myself up for the question to do you use Kotlin Multiplatform and
we've talked a bit about it. I mean, there is discussion of, without obviously giving away too much, about sort of the possibility of companion apps and even also some back-end capabilities that we're building out in terms of the possibility of sharing code there. So I definitely think it's something we will hopefully use at some point, but nothing concrete right now.
Okay, cool. And yeah, last question. So really, I looked at Ktor for the back end and really like the simple setup. I haven't really used the client much. How would you compare the client to like Retrofit or other ones like that? I know Ktor has pretty multi-platform built in, but other than that, how do you find them?
I mean, it's for the most part very similar. Maybe I haven't used it enough to sort of stretch the, I would have used Retrofit quite a lot over the last good number of years. And, it has nice support for setting up interceptors for some, various authorization use cases and so forth. I believe that's there. I haven't tried it out with Ktor. But from what I've seen so far, it's very similar. I mean, you define a sort of, you've effectively got some APIs that you can, I suppose the approach is a little bit different. I suppose Retrofit defines this interface, which it provides an implementation of. But under the hood, Ktor or Retrofit supports suspend functions now, in the same way that Ktor uses it. It supports automatic mapping, your JSON using JSON, for example, or Moshi or whatever. So, the libraries can mix and match, but fundamentally the same approach, I think.
Okay, cool. So yeah, I think that's all the questions. Yeah, we run a little bit over, so thank you very much for your time, John.
Appreciate folks in Athens at 9:10, is it?
Yeah, yeah, absolutely.
Thanks for staying on.
Yeah, no, definitely looking forward to trying out this People in Space repo and trying to make my side project app multi-platform.
Yeah.
But yeah, that's awesome. Thanks very much, and thanks again, everyone.
Very welcome.
Thank you, guys. Bye-bye.
See you guys.
Thank you. See you.
Bye.